Here's example 13 of solving trig equations. So here we have 2 sine squared of x minus 3 sine x plus 1 equals 0. And we're solving in this interval 0 to 2 pi. So again, all that means is just, so here we're solving for x. So since we're solving in this interval, that just means that 0 is less than or equal to x is strictly less than 2 pi. Okay, now this one's a little bit different in that here we have a sine squared and a sine, so how do we approach this? So we will do some basic algebra like we did in the last couple of examples, but it's going to be a little bit different, and it might not be obvious what to do right away. But notice what we have here. Here we have sine of x, and then here's the sine squared of x. So what we have is a thing, and then that same thing being squared. Okay, so what does that kind of remind you of? So think about something, and then something squared. So you have a thing, and then that thing is being squared. So it's kind of like a quadratic equation, right? So in a quadratic equation, you have like an x and then an x squared, things like that. So the point is you've got a thing and then a thing squared. So what we're going to do here is make a substitution to make this easier to work with. So I say this in all the substitution videos I do, or most of them anyway, but a substitution is something that's never really necessary, so to speak, but what it is, a substitution just takes something big and ugly like this, and it makes it smaller and prettier and easier to work with, and it turns it into something basically more familiar. Okay, so what we're going to do is say, let a equal sine of x. Okay, so we're going to take this sine of x and we're going to call it a. Why a? Well, why not? We'll call it whatever we want except for x, because x is already taken. But a, we'll just call it a for no real reason. We can call it whatever we want besides x. So let a equal sine of x, then a squared equals sine of x, quantity squared, right? But remember that sine squared of x is just a short way of writing that, okay? So a equals sine of x, so that means a squared is sine squared of x. So how does that help us? Well, now look here, sine squared of x, this is a squared. And then here, sine of x, that is a. So what does that do for us? Well, that now this equation has become 2a squared minus 3a plus 1 equals 0. And this, so this equation right here compared to this one is much simpler, much easier to work with, and it's much more familiar, right? So we're used to stuff like this maybe from our pre-calculus college algebra days, or maybe even before that. But here it's just a regular plain old quadratic equation, and how do we solve that? Well, one way is we can use the quadratic formula, but that's kind of going to be overkill because this actually can be factored. So if we want to factor this, it's going to be factored into 2a minus 1 times the quantity a minus 1. Okay. So from here, so when we work with this equation here, we're just completely forgetting about all the stuff up here, forget about the sine function, just forget about all that, and just focus on here. Now we're just going to solve this quadratic equation. And then eventually, once we go a little bit further, then we're going to go back into the trig stuff. But for now, just focus on this. So just a plain old quadratic equation, factor it like we learned in previous courses, and then it's just going to be 2a minus 1, a minus 1 equals 0. So then 2a minus 1 equals 0, or a minus 1 equals 0. So add 1 to both sides, and then 2a equals 1, divide both sides by 2, a equals 1/2. Here, just add 1 to both sides, that's it. Okay. Now we're not done, right? Because we're not solving for a, because remember a is the sine of x. We're solving for x. Here we're supposed to solve for x. So now at this step, this is where we go back into the trig stuff. Okay, so a equals 1/2, a equals 1. So let's come up here now. A equals 1/2 and a equals 1. Okay, but a is the sine of x. So if a is 1/2, then the sine of x is 1/2. Okay. Also, a equals 1, but a is the sine of x. So if a equals 1, then the sine of x equals 1. Okay. So now we back substituted, we got rid of the a, and now we're back into sine of x. So now from here, it's just a matter of knowing the unit circle. So sine of x equals 1/2. What are the values of x between 0 and 2 pi, like this up here? What are the values of x between 0 and 2 pi that have sine of x equal to 1/2? So really, it's just a matter of knowing the unit circle. And these values of x are x equals pi over 6 and 5 pi over 6. Okay. What about over here? Sine of x equals 1. what are the values of x between 0 and 2 pi such that sine of x is 1? Well, there's actually only one such value, and it's pi over 2. Okay, sine of pi over 2 is 1, and that's the only value of x between 0 and 2 pi with the sine value of 1. Okay. So that's pretty much it for example 13. So just to recap, what we did here was in the beginning, what was different about this example is we made the substitution. And again, substitutions are not really necessary. They just take something big and ugly and complicated like this and make it, they make it look like something a little more familiar, easier to work with like this here. But we didn't have to do that. We could have just factored this directly, and we could have said, so just as a side note, we could have factored that directly, and we could have just said 2 sine x minus 1 times sine x minus 1 equals 0. And we could have just solved this equation, so without even bothering to work with the a's here, but making the substitution, you know, it's if you're not really used to these types of equations here, it's probably kind of difficult to see that or think about it. But if we just say, okay, let's take this sine of x and just call it a, we'll call it something simpler, just call it a, or b, or c, or y, or z, or t, or whatever we want, besides x that's already taken, then that takes this equation and transforms it into this simpler, much more familiar equation, and this is easier to work with. Okay, so that's really the point behind substitutions there. So after we did that, we just solved the quadratic equation by factoring, and then very important to make sure that we back substitute. So a is the sine of x, so if a equals 1/2, then sine of x is also 1/2. A equals 1, but a is the sine of x, so sine of x also equals 1. And then from this point on, it's just a matter of knowing the unit circle. And that's pretty much it for example 13 of solving trig equations.